We're now going to introduce a new number system called the complex number system. The complex number system simply takes the real numbers and expands upon them. Let's look to see where these numbers originate from. We tried to solve the equation x squared equals -1. We would be unsuccessful in the real number system because there is no real number whose square is -1. To resolve the issue that this particular equation has no solution, mathematicians devised a number that they call I such that the square of I is equal to -1. Therefore, the number I is by definition the square root of -1. These numbers lead to the complex numbers. Complex numbers are numbers of the form a plus bi, where a and b are real numbers. The real number a is called the real part of the number a plus bi, and the real number b is called the imaginary part of a plus bi. If you look at the form of the complex number a plus bi, if we let b equal 0, you should notice that we get the number a, where a is a real number. What this means is that the real number system is a subset of the complex numbers. So if you're told the following number is a complex number, it does not necessarily mean that it contains the imaginary unit I. Let's go ahead and do an example. Here what we're going to do is add complex numbers. In order to add complex numbers, what we need to do is add the real parts, and then we go ahead and add the imaginary parts. Remember, the real parts are the number a, the imaginary part is the coefficient on the value I. So 3 plus -2 is 1, 5 plus 3 is 8. Therefore, 3 plus 5i plus -2 plus 3i is 1 plus 8i. What if we wanted to subtract complex numbers? Well, to subtract complex numbers, you subtract the real parts, and then you subtract the imaginary parts. So we would get 6 minus 3 plus 4 minus 6i. 6 minus 3 is 3, 4 minus 6 is -2, so the result is 3 minus 2i. Now that we know how to add and subtract complex numbers, we're going to go over the multiplication of complex numbers. Suppose we wanted to multiply 5 plus 3i and 2 plus 7i. Well, to perform this multiplication, all we need to do is use the distributive property. I'm going to take the 5 and distribute it into the expression 2 plus 7i, and then I take the 3i and distribute it into the expression 2 plus 7i. The result is the following. I get 5 times 2 plus 7i plus 3i times 2 plus 7i. Now, when I distribute the 5 into the first expression, I get 5 times 2, which is 10, and I get 5 times 7i, which is 35i. Then 3i times 2, distributing here, gives me 6i. 3i times 7i gives me 21i squared. Now what I'm going to do is combine like terms and do a little bit of simplification. 35i plus 6i is 41i. Remember, by definition, I squared is equal to -1, so I get 21 times -1. 10 minus 21 is -11, so the result is -11 plus 41i.